Okay, so looking at trigonometry. Now the hint that we're going to be using trigonometry is we've got a right angled triangle and there's an angle within them. So looking at this one on the left to start with, because we're going to work out the missing length in these two triangles, I'm going to start with this one on the left. So we've got an angle of 43, and the only thing I have to remember here is how to spell Sohcahtoa. So Sohcahtoa. There we go. Now that's just going to help me to know which I'm going to use, whether I'm going to use sin, cos or tan. So the first thing I need to do is I need to label this triangle to see what sides we've got. So opposite the angle that we're using, that's called the opposite. The longest side, which is opposite the right angle, is always called the hypotenuse. And the final side there is called the adjacent. Now there's one of the sides here I don't need to be thinking about. I need to use the opposite. I'm looking for the hypotenuse, so I don't need the adjacent. So let's have a look at what formula triangle we're going to use. Well, O and H, opposite and hypotenuse, is within my sine triangle there, SOH. We've got O and H within that triangle, so I'm going to use Sohcahtoa. The part of Sohcahtoa I'm going to use is sine. Now the side that I'm looking for is the hypotenuse up here with the x next to it. So hopefully you're used to using formula triangles. I'm going to cover up the H. Okay, so the sum that I need to do to find the hypotenuse is O over S, or O divided by S. So that's O divided by sine. So to find the hypotenuse, I'm going to do the opposite, which is 6, and I'm going to divide it by sine. All I need to remember is to put the angle here, 43, with sine. So sine 43. So sine 43 tells me the relationship between the opposite and hypotenuse, and in this case we're going to do a divide. O on the top, S on the bottom. Don't forget to put 43 in the bracket there for some of your calculators. So 6 divided by sine 43 on the calculator, 6 over sine 43 is 8.79 centimetres. I'm going to round that to 2 decimal places, and it actually comes out as, if I write a few down, it's 8.7976. The question will tell you how to round it. So if I round it to 2 decimal places, that would be 8.8 actually, 8.8 or 8.80. Let's round it to 1 decimal place. So we've got 8.8 centimetres for that first question. Now if we have a look at the one on the right, so question 2, we've got a very similar process here. Let's have a look. So we still have a look at our angle, label the sides, so opposite that is our opposite. And then we've got the hypotenuse here. And again, the adjacent ends up being down the bottom based on where that angle is. Now again, we need the opposite because that's the one we're looking for. We need the hypotenuse because that's given to us, but we don't need the adjacent again. So again, I'm going to be using my sine triangle because I've got O and H. I'm going to rewrite it again. So I've got SOH, but this time we are looking for the opposite. So I'm going to do the same process again. I'm going to cross off the opposite, and that tells me that I'm going to do a times. I'm going to do S times H. Now S again stands for sine. I just need to put the angle with it. So this time it's 36. So sine 36, making sure you put it in a bracket again, times by the hypotenuse, which is here, which is 9. So sine 36 times 9. And again, typing that into a calculator, sine 36 times 9 gives me an answer of 5 point, and if I round it to 1 decimal place again, well, it comes out as 5.29. So to 1 decimal place, that would be 5.3 centimetres. And again, just thinking logically here about whether your answer makes sense, because it can't be longer than the hypotenuse there, so it can't be longer than 9. So you should know if you've done it wrong, because it might end up coming out longer than 9. So that's finding side lengths using Sohcahtoa. When it comes to finding an angle, we've got a very similar process. I'm going to have a look at this question. It says find the sides of angle ABC. So from A to B to C, that gives us this angle down here. And again, I'm going to follow the same process. So opposite that angle is over here. Our hypotenuse is opposite the right angle, and our adjacent side is down here. So it looks like I've got a different bit of Sohcahtoa to use this time, because this time I don't need the opposite, but I do need the hypotenuse and the adjacent. So again, just write down Sohcahtoa. And we're looking for the formula triangle, this time that has the H and the A in, the hypotenuse and the adjacent. So the H and the A is in my cos triangle, so I'm going to be using this one. Now we're looking for the angle this time, so if I cover up the angle part, which is the C, it tells me that I need to do A over H. Now if we just do that, A is 7 and H is 13. Now if I just type that into the calculator, 7 divided by 13 just gives me a decimal 0.538. Now the calculator doesn't know that this time I'm looking for an angle, so all I'm going to do to tell the calculator I'm looking for an angle is first I'm going to press shift and then press cos so shift cos. And on your calculator, it'll come up with, and let's get it on my calculator here, you get it saying cos -1. And that just tells your calculator, this time I'm looking for the angle, and this is the fraction I want to put in. So you type in cos -1, and then 7/13, and if your calculator has the fraction function, you can put it in as a fraction. If not, in the bracket there, just put 7 divided by 13. So let's do that. Cos -1, 7 divided by 13, or 7/13 is a fraction, and you get the answer here, 57.42. And if we round that to 1 decimal place, it'd be 57.4 degrees. There we go, for an angle. So it's the same process no matter which formula triangle you use. You just have to identify the sides, and then when you're looking for an angle, you're always going to press shift cos, shift sine, or shift tan, and you'll get this little symbol here, cos -1. Now there are a few non-calculator questions, and again there's more of these on the higher, but two here that we really need to know, and that is sine 30 and cos 60. Now the value of sine 30 is 1/2, as is the value of cos 60. So they're both equal 1/2, and they're really good ones to make sure that you know for these non-calculator papers. Okay, so do remember those ones, sine 30 and cos 60, and they're both equal 1/2. And let's see how we can use that. So this question says, given that sine 30 is 1/2, which hopefully we know anyway, work out the length of AB, and AB is this side here. So let's label this triangle up. We've got the opposite, we've got the hypotenuse, which it's asking us to look for, and this is our adjacent again. Now again, we're not going to use the adjacent here, we're just going to use O and H. And if we remember our little formula, look, SOH has the O and the H in, and we're looking for the hypotenuse. There we go. So if we're looking for the hypotenuse, we cover up the H, and we need to do O divided by S. So S is my sine 30, so if I was to do this on a calculator, I'd have to do 4, and I'd have to divide it by sine 30. Okay, but this question's actually told us that sine 30 equals 1/2, so actually what I'm doing is 4 divided by 1/2. I'll write that as a decimal, it makes it a little bit nicer to see, but 4 divided by 0.5. So actually it's just asking me to do a number sum now, which is 4 divided by 1/2, and if you divide by 1/2, it doubles the answer there, doubles the number. So 4 divided by 1/2 is 8, so my answer would be 8 centimetres. There we go. And of course that could go the other way around as well. I could have to do a times. So had it not given me this 4 here, maybe it had already told me that this was 8. Then instead I would do 8 times 1/2, doing S times H, so 8 times 1/2, and that would give me the 4 here that's been given as the opposite. So we could have it either way. Okay, so we're going to have to work out some missing lengths in this triangle. Now it's not a right angled triangle, so to find missing lengths and angles we can use either the sine rule or the cosine rule. And these are rules that you're going to have to remember. But we're going to have a look at one to start with and how we know when to use it. Now the first thing you do is you try and identify in a triangle, for first of all what we're looking for, which is AB. So let's label that X. Now what I look for straight away is, do I have pairs of opposites? So I have this pair of opposites here, and I've got both of those. And then I've also got X opposite to this angle. So I don't have X, but it's in one of my pairs of opposites. So when we've got this scenario where there's two pairs of opposites, we can use the sine rule. And we only ever need part of the sine rule, so I'm just going to use A over sine A equals B over sine B. Also equals C over sine C, but we only ever need to use 2 of them here. So let's have a look. We need to label this up. Now I'm going to completely ignore the letters that are on the actual triangle itself. I'm going to label this angle A, which it already is, and this side little a opposite that, and then this angle B, and the one opposite little b. And all I need to do now is stick all the numbers into the formula. So let's have a look. A is 12, so it's 12 over sine the one opposite that, 55, is equal to B, which is our X, over sine B. Obviously you should already know there's two variations of this formula. We could have it flipped over, so we could have sine A over A equals sine B over B, but this is our one for side lengths, and we know that because our unknown piece is on the top, so we're able to isolate this now quite easily. So, sorry, I've written B there, it should be 20. There we go, sorry, there we are, 20. So all we need to do is times both sides now by sine 20. What you could do is work this out on your calculator and times your answer by sine 20, but I'm going to multiply it straight over so I can type it all in one go. So times by sine 20. And if we do that, we get 12 sine 20, it goes onto the top there, over sine 55. There we go. And all we have to do is type that into your calculator, obviously just being careful that you put these angles in brackets. Some calculators are going to need you to do that. So if we type that all into the calculator, again, not forgetting you could just work out 12 over sine 55 first and then times it by sine 20, but I'm just going to go for it like this. So 12 sine 20 on the top, closing your bracket, over sine 55. And on your calculator, just writing down what you got 5.01033539998. Now a question would normally say how to round this, so if we imagine it was 2 decimal places for this one, it would be 5.01, and it's a length, so centimetres. Okay, so just obviously just be careful what the question says. Let's have a look at an idea where we've got to find the angle. Okay, so in this question, let's have a look. Work out the size of angle BAC. So let's identify that. That is here, BAC. Okay, so we're going to use the formula the other way around this time. So sine A over A equals sine B. That does not say sine B. Sine B over B. Okay, so plugging in our numbers, let's just label it up. So let's call this one A, as the A is next to it, that's fine. And again, I'm just going to write over this one, I'm just going to put B and B. Okay, just because of the way I've written my formula. So then sticking in all the numbers, what have we got? Sine A is sine X, so we have sine X over 20, equaling sine 43 over 14. Okay, so exactly the same approach as we did before. We can isolate the sine X by timesing both sides by 20. And again, you could work that right hand side out and times it by 20, but I'm just going to go stick it up the top there. So we end up with sine X equals 20 sine 43 over 14. And if we type that into the calculator now, what do we get? 20 sine 43 over 14, and we get an answer here. Let's write it over here. So we get sine X equals 0.97428 and a few more decimals. And obviously, just like normal trigonometry when you're doing SOHCAHTOA, to get the actual X here, we have to do the inverse of sine. So we're leaving that number on your calculator. You do shift sine, which gets you sine minus 1. Type in that answer or just press your answer button. So shift sine, answer, press equals, and I get an answer here of 76.9779. And again, a question would ask us to round it here. Just depends. So let's just go to the nearest degree. We go for 77 degrees. Obviously, just making sure what the question says here, but let's just round it to the nearest degree there. So 77. Okay, so that's how you use the sine rule. Right, let's see how this question's different then. So work out the length of AB. So this one over here. Now straight away, looking at this, look, we've got a pair of opposites there, but I don't have any other pairs of opposites. I've not got anything opposite my 15, I've not got anything opposite the 12. So I can't actually use the sine rule here, and that is your clue, that is your hint here, that the sine rule's not going to work, and we're going to have to use the cosine rule. So another rule that you need to know, so the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so a being the side we're looking for, so we'll label this little a and this one big A, ignoring the letters on the triangle, and then labelling the other two sides, and they can be B and C, however you like. And from there, all you've got to do is stick these numbers in. It's actually quite simple to use when you know it. So a squared equals b squared, which is 15 squared, plus c squared, which is 12 squared, minus, and I'm going to stick this bit in brackets, 2 times 15 times 12 cos a, which is down here, which is 20. There we go. Right, so sticking that all in the calculator, let's have a look what we get. So 15 squared plus 12 squared minus 2 times 15 times 12 cos 20. Press equals, and I get a squared equals 30.7106 and a few more decimals. Now obviously that is a squared, and we don't want a squared, we want to know what a is, so we just need to square root both sides now. So square root, leaving the answer on your calculator, square root answer, and we get a equals 5.54 1719. And again, obviously you'd be asked to round this in a particular way in the question. Let's go for 2 decimal places, so A equals 5.54 centimetres. Right, there we go, and there's using a bit of the cosine rule. Okay, so working out the size of angle BAC, which again is this one at the top. And again, just having a look, there are definitely no opposites because we've got no other angles. But the angle that we're looking for is going to be our A, and it is opposite 9. There we go, so the others can be B and C again. Now, obviously here we're looking for an angle, so it's up to you if you choose to learn the formula. I tend to find that I just learn this formula, A squared equals B squared plus C squared minus 2BC cos A. And then I'm quite happy just rearranging that to get cos A on its own. So in order to do that, I'm going to get this whole minus 2BC cos A. I'm going to add it to the other side. So we get A squared plus 2BC cos A equals B squared plus C squared. Now I can get rid of that A squared, so we can minus A squared from both sides, so minus A squared, and you get 2BC cos A equals B squared plus C squared minus A squared now. And now you can finish off this rearrangement. You can divide by 2BC just to leave you with cos A. So cos A equals B squared plus C squared minus A squared over 2BC. It's up to you. You can choose to just learn that formula if you want, but that's the formula we're going to use to find an angle. So plugging in all these numbers then just into my formula there, we'll get cos A equals B squared plus C squared, so 10 squared plus 5 squared, minus A squared, so minus 9 squared, all over 2 times B times C, so 2 times 10 times 5. Nice and easy typing that into the calculator, so fraction button, 10 squared plus 5 squared minus 9 squared, all over 2 times 10 times 5. And that equals, let's have a look, so cos A equals 0.44, and then same process again, we need to do the inverse of cos, so cos minus 1 of your answer, and you get, let's have a look, shift cos, answer, and I get 63.896, there we go, degrees. And again, we could round that, so we could just say 63 point, and let's just go to 1 decimal place, 63.9 degrees. Again, just reading the question. And that's how to use the cosine rule for finding angles. Moving on to the area of a triangle. So your area of a triangle formula, obviously not half base times height, because we don't have the height here. So for any triangle, the area is half AB sine C. So half AB sine C, another formula there that you need to know. And let's just have a look at how we apply that. So sine C, this time the angle that we're going to use is going to be our C. So we'll call that C. This would then be little c, and the others will be A and B, and they can be A and B in either order. And then it's as simple as just sticking those numbers into a formula. So it's half times 5 times 8 times sine 41. There you go. Type that into the calculator. So half times 5 times 8 times sine 41. And we get the answer 13.12. If I round it to 2 decimal places, it's area, so that's metres squared, just being careful of the units, so 13.12 metres squared. There we go, there's using the area of a triangle formula. Question like this though, you might be given the area of the triangle, so it says the area is 80, so we're working backwards a little bit here. So we're going to use half AB sine C again, so half AB sine C, but this time it gives us the answer, so the answer to that half AB sine C has to equal 80. So let's just plug in all the numbers here, again C being my angle, and then A and B being my other lengths. So if I was to type this into the formula, we'd have a half times 11 times 16 times sine C, and it would equal 80. Now I can't actually work that out, but what I can do is I can work this bit out. So if I do a half times 11 times 16, we get the answer 88. So we have 88 times sine C equals 80. So we can rearrange this, look, we can get both sides and divide them by 88, and that will just give us sine C on its own. So sine C equals, and 80 divided by 88 is, let's leave it as a fraction, well, actually it is a decimal there, but it comes out as 0.90, and that is actually 90 recurring. There we go, I'm just going to leave it on my calculator screen. And then obviously to finish that off, you do the inverse sine again, just like we have on these other questions. So I'm going to do that over here to the left. So sine minus 1 of this number here, which is actually also a fraction, it's 10 over 11. Sine minus 1 of 10 over 11, or that 0.90 recurring. And we get the answer of 65.38 degrees. There we go, so we can find an angle as well, just working backwards if we're given the answer. And you can apply that logic there to lots of different questions where it gives you the answer and you can use your formula backwards, just dividing everything over to the other side.